Overview. The aircraft is powered by 4 Allied Signal LF507-1F twin-spool high-bypass ratio turbofan engines. The low-pressure spool drives a geared fan, which provides most of the engine's thrust. Each engine is flat-rated at 7,000 pounds thrust, up to 23.3 degrees C at sea level. AC electrical generators are fitted to engines 1 and 4. Hydraulic pumps are fitted to engines 2 and 3. Fuel flow to each engine is controlled by a full authority digital engine control, FADEC, with mechanical reversion. An auto-throttle system allows full thrust modulation by the flight guidance system. The engine is protected against ice by the use of engine bleed air and internal hot oil spray. A fire detection system provides indication of over-temperature, and 2 fire extinguishers on each engine may be used to stop the spread of fire. The engine. The engine comprises 4 modules: a fan module, a gas producer module, a combustor turbine module, an accessory gearbox module. Air passing through the fan is divided by a splitter. Most of the air is accelerated through the bypass duct and provides the primary means of thrust. The remaining air passes through a 2-stage low-pressure compressor called a supercharger. The supercharger compresses air and delivers it to the gas producer module. Here, air is further compressed to high pressure by a 7-stage axial compressor and a single-stage centrifugal compressor, after which it passes to the combustor turbine module. Fuel is delivered to the combustion chamber through multiple fuel nozzles. The fuel-air mixture is ignited and exits via a 2-stage high-pressure turbine, which drives the high-pressure compressor stages. Before exiting to atmosphere through the jet pipe, the hot gases pass through a 2-stage low-pressure turbine, which drives the 2-stage supercharger and fan via a reduction gearbox. Each engine is fitted with an accessory gearbox, driven by the engine's high-pressure compressor. The services driven from each gearbox differ, depending on the position of the engine. The services driven from each gearbox are an AC generator, outboard engines, or a hydraulic pump, inboard engines. A fuel boost pump. A fuel control unit, called a hydromechanical unit, HMU, which incorporates a high-pressure fuel pump. An oil pump. Additionally, each accessory gearbox is fitted with an electrical starter motor. A drain mast is fitted on the bottom of each engine cowling and contains sealed drain lines for the constant speed drive of the AC generator, outboard engines, the hydraulic pump, inboard engines, the HMU, the fuel boost pump, the engine starter drive. Bleed air is extracted from 3 separate points on the engine for air conditioning and ice protection. The upper bleed port is used to supply airframe ice protection and air conditioning, and the other 2 bleed ports are used for engine ice protection. Engine anti-ice. The fan spinner is continuously anti-iced by an internal oil spray. The airflow splitter and air intake lip are anti-iced by separate systems, with hot air bled from the final stages of compression. Bleed air is controlled by 2 anti-ice valves on each engine, which are selected open by a single switch on the engine ice protection panel. The valves are electrically powered shut and pneumatically actuated. Selection of engine anti-ice illuminates engine anti-ice on the central status panel. When the airflow splitter anti-ice valve is open, engine valve not shut illuminates on the ice protection panel. This indicates that hot air is being delivered to the splitter. 2 annunciators on the ice protection panel indicate operation of the intake lip anti-ice valve. Intake low pressure indicates low air pressure beyond the intake anti-ice valve. This should extinguish when the engine is operating above flight idle. Intake high pressure indicates that the intake anti-ice valve has failed to regulate the bleed air pressure correctly. Either of these cautions are accompanied by ice protection on the central warning panel. To prevent engine surge during start, the engine anti-ice valves are automatically opened. To protect against high EGT during engine start after starter cutout, engine anti-ice is selected on before start. Bleed band. In order to allow correct response of the engine during starting and periods of engine acceleration and deceleration, air is bled from the high-pressure compressor by the opening and closing of a bleed band assembly. This device is electrically controlled from the FADEC. Fuel system. Fuel is delivered by the AC fuel boost pump in the wing feed tank through the low-pressure shut-off valve, which is controlled by the fire handle, to the engine-driven low-pressure fuel pump. It then passes through a fuel heater to a low-pressure filter. If the filter becomes blocked, filter clogged will light on the central warning panel. Fuel then passes through the hydromechanical unit, HMU, which contains a high-pressure pump, a metering valve and a high-pressure shut-off valve. Under normal operations, FADEC controls the metering valve. The high-pressure shut-off valve allows the engine to be stopped and is controlled directly by the thrust lever. From the hydromechanical unit, fuel is fed to the fuel nozzles in the combustion chamber. Ignition. During engine start, ignition is provided by either ignition system A or B or both, as selected by the pilot. Ignition is automatically terminated when combustion becomes self-sustaining. The ignition system is then not normally used for the remainder of the flight. However, continuous ignition A or B must be selected on when operating from contaminated runways and when flying through areas of severe turbulence or heavy precipitation. Selection of either continuous ignition A or B illuminates Engine ignition on the central status panel. Engine ignition is also used during an in-flight start. This is covered in the engine starting module. Oil system. The oil system is completely self-contained and includes an oil tank, oil pump, oil fuel heat exchanger, and filter for each engine. Oil is replenished at the oil tank, which contains a dipstick and a transmitter for the oil contents gauge on the flight deck triple gauge. The oil pump, which is located on the accessories gearbox, also contains the oil filter. Low oil pressure is indicated by Oil Low Pressure on the central warning panel. Fire warning and suppression. Each engine is divided into two zones for engine fire detection purposes. The area between the fan casing and the cowling is termed Zone 1. The area between the engine core and the core casing is termed Zone 2. Each zone is equipped with two fire detector loops, designated Loop A and Loop B. Each pair of loops is connected together in parallel to form two independent detection systems. Both systems give identical fire indications. Either pair of loops may be selected as the active detection system on the engine fire detect panel. It is normal airline practice to alternate the selected loop on either a daily or sector basis. Failure of a detector loop will illuminate Loop Fault for the appropriate engine. When an overheat condition is detected by either loop, the following warnings are given. A red light in the appropriate thrust lever. The appropriate engine fire caption on the central warning panel. Both red attention getters. A red light in the appropriate fire handle. A fire bell. The fire bell and red alert flashes may be cancelled by pressing either of the red alert flashes. All the other warnings will cancel when the temperature at the sensor falls below a preset limit. The fire warnings for each engine may be tested by the use of 4 Engine Fire test buttons on the ground test panel. All the fire warnings for that engine plus the following warnings are activated. The appropriate loop fault caption on the central warning panel. Both amber attention getters. When an engine fire is detected, it is important to isolate all the surfaces on that engine which may support combustion. This is done by the use of 4 fire handles, one for each engine on the overhead panel. Each fire handle requires 3 distinct actions to be pulled to its full extent. Pulling to the first bulk illuminates Engine Fire Handle on the central warning panel. This indication is provided in order to confirm that the correct fire handle has been operated. Twisting the handle to move it through the bulk and pulling to the full extent achieves the following. Electrically closes the relevant engine air valve to ensure that no products of combustion enter the aircraft air supply system. Electrically isolates the engine-driven generator, handles 1 and 4, to protect against electrical fire. Electrically closes the engine-driven hydraulic pump isolation valve, engines 2 and 3, to ensure that hydraulic fluid is not supporting combustion. Mechanically closes the engine low-pressure fuel valve to isolate the engine from its supply of fuel. It should be noted that the primary means of isolating fuel from the engine is by means of the high-pressure valve, which is closed by use of the thrust lever as part of the actions required following engine fire. A fire extinguishing system is fitted in Zone 1. A fire in Zone 2 may only be extinguished by shutting the engine down. 2 fire extinguisher bottles are fitted in the nose cowl of each engine and are electrically activated to operate independently by turning each fire handle either anti-clockwise, shot 1, or clockwise, shot 2, after the handle has been pulled to its full extent. Confirmation that a fire extinguisher has been signalled to operate is given by either extinguisher number 1 used or extinguisher number 2 used illuminating on the overhead panel for the appropriate engine. These warnings may be tested by pressing Engine and APU extinguisher on the ground test panel. APU extinguisher used also illuminates on the APU panel. To protect against extinguishing thermal expansion, each fire bottle is provided with a pressure relief valve and indicator located on the inboard and outboard side of each nose cowl. These indicate red if a fire bottle has been discharged due to thermal expansion. 2 combined fire access and pressure relief doors are also fitted on each engine. Engine indications. Engine vibration level, fan speed N1, exhaust gas temperature EGT, gas generator speed N2, fuel flow, fuel used, and fuel contents are indicated by the primary engine display, PED. Oil contents, temperature and pressure are indicated on 4 separate gauges. Engine vibration. This is indicated in inches per second. An indication exceeding 1.2 inches per second will activate the engine vibration caption on the central warning panel. Operation of the vibration test button on the center panel causes the reading to increase to 2.0. N1 set. Target N1 as computed by the flight guidance system is displayed in the N1 set window and as an amber command bug on the N1 gauge. Following failure of the TRP, AF ARINC fail appears in the N1 set window. N1 can be manually set by pulling the Pull Set N1 knobs at the bottom of the primary engine display and rotating to the required value. When the target is set manually, a letter M appears in the N1 set window as a reminder to the pilot. The color codings on the N1, N2 and EGT gauges have the following meanings. Green arc, normal operating range. Yellow arc, takeoff or precautionary range. Red radial mark, maximum or minimum safe operating limit. Red dot, maximum transient overshoot. N1. N1 is indicated as a percentage of maximum fan speed. The maximum operating limit is 97%, which is both the takeoff and the maximum continuous limit. Actual N1 is indicated by a pointer. When actual N1 matches commanded N1, the pointer lies within the command bug. A transient overshoot of 100% is permitted for a maximum of 10 seconds. EGT. Gas temperature measured in the jet pipe is indicated in degrees C. The normal operating range extends to 613 degrees C, defined as maximum continuous thrust, MCT. The takeoff range extends to 632 degrees C and is indicated by the red radial. However, the maximum operating limit of 649 degrees C is defined as the EGT limit during engine start and wind shear recovery. A maximum transient overshoot of 713 degrees C is permitted during engine start for a maximum of 15 seconds. N2. N2 is indicated as a percentage of the maximum core speed. The maximum normal operating limit is 96.9%. The yellow arc or maximum takeoff limit extends to 98.8%. A transient overshoot of 100% is permitted for a maximum of 10 seconds. Maximum operating limits. When a maximum operating limit of N1, N2 or EGT is exceeded, the leading block illuminates. If this contains a digit, it appears in inverse video. If the exceedance lasts for more than 10 seconds, the whole numeric display will flash. Fuel used and fuel flow. When no fuel flow is present, the display shows kilograms or pounds dependent on the aircraft configuration. After engine start, fuel flow is indicated. When push fuel used is pressed, the display shows fuel used, but reverts to fuel flow 10 seconds after the button is released. The fuel used counters may be zeroed with the reset button, but will automatically revert to zero after about 20 minutes without electrical power. Triple gauges. A triple gauge for each engine provides indication of oil quantity, pressure and temperature. Thrust rating. Thrust is set by reference to fan speed, N1, which is measured as a percentage. 100% corresponds to 7,600 RPM. At sea level, at 23.3 degrees C, with a standard pressure setting, 95.1% N1 will give the rated thrust of 7,000 pounds. Below this temperature at 95.1% N1, thrust will increase above rated thrust. To prevent engine damage, thrust is limited to 7,000 pounds below 23.3 degrees C by limiting N1. This is known as flat rating. Above 23.3 degrees C, thrust falls as the density of the air decreases and the takeoff EGT limit of 632 degrees C is maintained. This is known as full rating. The maximum thrust rating at any temperature is known as N1 reference. N1 ref. Fan overspeed protection. If N1 exceeds 104%, the engine will automatically shut down, and the caption "Engine Overspeed" will light on the central warning panel. An engine overspeed test button is provided on the ground test panel, which multiplies actual N1 by 4 and feeds the signal to the overspeed controller on the appropriate engine. Thrust control system. The thrust control system comprises the thrust levers, full authority digital engine control, FADEC, the thrust rating panel, TRP, auto throttle. Thrust levers. Each engine is controlled by an individual thrust lever. It is fitted with a balk to prevent inadvertent closure of the high-pressure fuel valve when the engine is at idle. A trigger mechanism fitted to each thrust lever allows the balk to be passed and the fuel valve to be closed. Between fuel off and idle is an intermediate fuel on position, which is used during a FADEC off start. The thrust lever is mechanically linked by cables to the HMU. Numbers 1 and 4 thrust levers have an autothrottle disconnect button on each outer side. Numbers 2 and 3 thrust levers have a toga button on their front face. This button signals the flight guidance system to engage the takeoff or go-around modes. A fire warning light is fitted in each thrust lever. FADEC. The FADEC system consists of an HMU and an ECU on each engine and provides the following functions: full authority control of engine parameters, N2 idle control on the ground and in the air for all ambient conditions and engine air bleed conditions, control of N1 for all thrust modes by interface with the flight guidance system. During FADEC manual reversion, the fuel metering valve within the HMU is mechanically controlled. Under FADEC control, the mechanical link is broken, and the thrust lever angle is electrically transmitted to the ECU, which then electrically controls the metering valve within the HMU. FADEC trim control of N1 is between 5% at high thrust settings and 18% at low thrust settings. The FADEC status panel above the PED contains the FADEC trim arrows and the FADEC fault off annunciators for each engine. The fault annunciator illuminates to indicate a FADEC failure. FADEC will also illuminate on the central warning panel. FADEC is selected off by pressing the fault annunciator. Following a FADEC failure or manual reversion at high thrust levels, the engine thrust is frozen until the thrust lever is retarded to the lower power region. Thrust rating panel. The TRP provides an interface between the pilot and the thrust control system. It allows the selection and display of any thrust rating as calculated by the flight guidance system and the setting and display of the EFIS speed reference bugs. In order to extend engine life, a takeoff thrust below maximum rated thrust is used. This is done by basing the takeoff thrust calculations on an assumed temperature which is higher than ambient, which produces a lower thrust. This is called a flexible thrust technique. This facility is available on the RJ, but the provision of a standard thrust reduction below rated thrust is available and should be used. When the aircraft is on the ground, the TRP is selected on by pressing the toga button. In flight, pressing any of the buttons on the front of the TRP will select it on. Toga Max is the default setting on the ground. Selection of the following modes provides appropriate N1 targets to FADEC and for display on the flight deck. Toga Max. The maximum rated thrust for takeoff and go around corrected for altitude and temperature. Toga Reduce. Provides a standard thrust reduction below maximum rated thrust in order to extend engine life. Alternatively, in this mode a temperature higher than ambient may be entered to produce a flexible reduced takeoff thrust. MCT. Selects maximum continuous thrust equal to N1 ref with an EGT limit of 613 degrees C. Climb norm. Selects the normal or reduced climb schedule. Climb max. Selects the maximum climb thrust rating in accordance with the performance schedule. Each thrust rating is continuously calculated for pressure altitude, temperature and bleed selection and is displayed on the PED and in the TRP window when the rotary selector is set to N1. By moving the rotary selector to temp with Toga Max as the selected thrust rating, the sensed OAT is displayed in the window when the rotary control is turned clockwise by one click. A correction to OAT may be made using the rotary control. The flight guidance system uses the lowest of the set and sense temperatures in its calculation of N1 ref. With Toga Reduce selected on the TRP, the temperature displayed will be T Reduce, a standard increase above OAT. N1 Reduce is now displayed on the PED. T Reduce may be manually amended to any temperature above OAT to produce T Flex and a related N1 Flex. Due to manufacturing differences, each engine produces a different thrust for a given N1. To ensure that rated thrust is not exceeded at the maximum indicated N1, an electrical bias is applied to the N1 signal by FADEC to make all four engines appear to be at the same N1, without exceeding maximum rated thrust. When equal thrust is required, compensation is applied to the N1 signals to the primary engine display and the flight guidance system. This occurs when either Toga or MCT are selected on the TRP. Equal thrust is then achieved by each engine at apparent equal N1s. With Climb Norm or Climb Max selected on the TRP, the compensation is removed to synchronize the engine's true N1s and so reduce cabin noise. The TRP rotary selector is also used to enter the bug reference speeds V1, V cross and V dot on the EFIS speed tape. When V1 is selected on the TRP, a bug is placed against the speed tape and the V1 speed is repeated at the bottom of the speed tape. The V1 speed and bug disappear when the aircraft is in flight. The TRP is selected off by pressing either of the autothrottle disconnect buttons on the end of thrust levers 1 and 4 for longer than 3 seconds. Autothrottle. The link between the flight guidance system and the autothrottle servo motor adjacent to the thrust levers allows full authority thrust control by the flight guidance system. The autothrottle is selected on ARM, using the switch on the MCP. This can only be done if the TRP is on. Indication of autothrottle engagement is given by the green light adjacent to the switch on the MCP, and AT in white, armed, or green, active, on the PFD. The autothrottle is disengaged by using either of the autothrottle disconnect buttons on thrust levers 1 and 4, or by deselecting the autothrottle arm switch on the MCP. When the autothrottle is manually disengaged, AT on the flight annunciators illuminates for 4 seconds. And AT on the EFIS flashes for 4 seconds. An automatic disengagement is indicated by the above warnings, but they will remain until cancelled by pressing either autothrottle disconnect button. Operation of thrust control system. The thrust control system has the following modes of operation: manual reversion, thrust automatics off, thrust modulation, basic mode, thrust mode, auto throttle, speed mode, thrust mode. Manual reversion. This is the most basic form of thrust control, which is made by movement of the thrust levers, which are mechanically linked by cables to a fuel metering valve within the HMU of each engine. No engine parameter limitation protection is available apart from fan overspeed protection at 104% N1. N2 ground idle will be between 49% and 75%. In flight, the pilot must ensure that minimum N2 is manually set. Thrust automatics off. The FADEC is selected on. The thrust lever's control of the fuel metering valve in the HMU is disconnected, and the electronic control unit, ECU, now controls the metering valve electrically. The introduction of FADEC allows greater engine control and performs engine limitation protection and N2 idle control. N1 is limited to 97%. N2 is limited to 98.8% and EGT to 649 degrees C. Care must be taken when operating with the TRP selected off to ensure that the scheduled climb or takeoff thrust rating is not exceeded. Ground idle is controlled to 50% N2, but depending on environmental conditions, it may be between 49% and 54%. To guarantee engine acceleration, minimum flight idle is 60% N2. To ensure that sufficient air is still available to provide air conditioning when bleed demands are placed on the engine, a minimum N2 must be determined for all bleed conditions at all altitudes. This is known as the N2 floor schedule and is automatically provided by FADEC. The minimum N2 in flight with engine anti-ice selected on is 67%, but reduces to 60% below 200 feet radio altitude. Thrust modulation. Selecting the TRP on raises the thrust control system to the thrust modulation level and provides a link between the flight guidance system and FADEC. The FADEC now has a limited control authority as demanded by the flight guidance system. The FADEC provides limitation protection for N1, EGT and N2 in all modes with the following exceptions. When wind shear is detected, 649 degrees C EGT is allowed rather than the normal takeoff limit of 632 degrees C. With climb norm or max selected on the TRP with the autothrottle off, 632 degrees C becomes the limit rather than the normal maximum continuous thrust limit of 613 degrees C. Basic mode. This mode is entered when climb norm or climb max is selected on the TRP. All the N1s are synchronized to the N1 of the master engine as selected by the master switch on the TRP. If any thrust lever is moved away from the master engine, FADEC will eventually reach the limit of its trim authority and the pilot must advance or retard the thrust lever as indicated by the arrow on the FADEC status panel. A blue arrow to advance the thrust lever and a white arrow to retard it. The arrow will extinguish when FADEC authority is regained. Thrust mode. The thrust mode is entered from the basic mode by either selecting Level Change, Climb on the MCP, or selecting any thrust mode on the TRP. VADEC will now control N1 within its control authority. The blue arrows will again appear when the limit of control authority is reached. The current thrust mode will be displayed in the top left-hand corner of the PFDs. White when the mode is armed, and green when it is engaged. The calculated N1 is shown on the N1 set displays on the PEDs, along with the bug settings on the N1 gauges. The following thrust modes are available. Autothrottle. The autothrottle mode is similar to the thrust modulation mode. The flight guidance system controls N1 to a thrust schedule by moving the thrust levers using the servo motor instead of commanding the pilots with the trim arrows. The autothrottle may be overridden at any time by manually advancing or retarding the thrust levers. Autothrottle speed mode. This mode is similar to the thrust modulation basic mode, where the pilot controls N1 by moving the thrust levers. In the autothrottle speed mode, the autothrottle controls N1 to maintain either Mach or IAS as selected on the V-cell control on the MCP. Retard mode is entered after either a selection of level change during descent or automatically when radio altitude is below 50 feet. Autothrottle thrust mode. The thrust mode is engaged on takeoff, during a go-around and during a climb, with either takeoff or IAS engaged as the autopilot vertical mode. Engine Life Computer. The Engine Life Computer records certain engine parameters both routinely and when engine limitations are exceeded. Engine parameters may also be stored by use of the Store Data switch. The Fail annunciator illuminates either when the unit fails a built-in test or when the memory is greater than 80% full. External checks. The following checks must be made before each flight. The covers must be removed from the engine intakes before flight. The engine intakes and fan blades should be inspected for any foreign objects and damage. Both fire bottle indicators should be green. There should be no leaks evident from the drain mast. The engine exhaust must be inspected for damage. That completes the external checks for the power plant. The next section will cover normal operations. Pre-flight. After the batteries have been selected on, the engine fire test must be performed for all 4 engines. Starting with the number 1 engine, when the fire test button on the ground test panel is pressed and held, the following indication should appear. Fire extinguisher handle, red lamp. The captain's red and amber attention getters. Engine 1 fire, red caption. Loop 1 fault, amber caption. Engine 1 thrust lever light. Fire bell. The master warning system red alert light should be pressed to cancel the fire bell and the master warning system red alert and caution lights. When the engine fire test button is released, the following warning should cancel. Fire extinguisher handle, red lamp. Engine 1 fire, red caption. Loop 1 fault, amber caption. Engine 1 thrust lever red lamp. The engine fire test should now be completed for the remaining engines. The engine extinguisher used indications are now tested by pressing and holding the engine and APU extinguisher button on the ground test panel. The 8 engine extinguisher used captions illuminate while the test button is pressed. Note that this test also illuminates the APU extinguisher used caption on the APU panel. The 4 fire handles are checked fully in. The center panel is now checked. The oil pressure, temperature and quantity indicators are checked for condition and the contents checked. The FADEC fault and off annunciators should not be illuminated if all the FADECs are functioning normally. The engine vibration system is checked by pressing and holding the vibration test button on the center panel. The engine vibration indicators increase to 2.0 and engine vibration illuminates when the reading rises above 1.2. When the button is released, the vibration level reduces to 0. The N1 settings, both N1 ref and N1 redu, dependent on the pressure altitude, temperature, cabin air bleed and engine anti-ice condition, should now be calculated for takeoff. With the rotary knob on the TRP selected to temp and the toga button selected to max, rotating the rotary controller by 1 click will display the sensed OAT in the window. If this is different from the reported outside temperature, the reported temperature is entered in the window. The flight guidance system uses the lower of the two temperatures to calculate N1 ref. The calculated values should then be checked against the values calculated by the TRP, with the intended bleed selection for takeoff selected. This procedure is fully explained in the Performance module. The following configurations are permitted for takeoff. No bleeds. APU air selected on and packs on. Maximum thrust is available from the engines. Cabin air on. Engine air selected on and packs on. Discrete signals from any engine air switch and either pack switch combine to signal this configuration to the TRP. Engine anti-ice on. Engine anti-ice selected on and engine air off. A discrete signal from any engine anti-ice switch signals this configuration to the TRP. When this configuration is used, air conditioning is normally provided by the APU. The selection of APU air by itself does not affect the TRP calculated N1. It is not permitted to select engine air bleeds and engine anti-ice simultaneously for takeoff. If an invalid bleed selection is made with a takeoff setting on the TRP, the N1 set numbers on the PED will flash. If a reduced thrust takeoff is performed, N1 ref is normally manually set in the N1 set window of the number 1 engine for reference. N1 reduce appears in the other N1 set windows. The intended thrust rating for takeoff, either TOGA max or TOGA reduce, is set on the TRP. Note that the rating appears on the top left of the PFD. Reduced thrust must not be used for takeoff with flap 33 or if the runway is contaminated with standing water, snow, slush or ice. During ground maneuvering in wind speeds greater than 15 knots, do not exceed 55% N1 except for takeoff. The engine anti-ice must be on during all ground and flight operations when icing conditions exist or are anticipated, or if the ice detected caption is illuminated. In flight. Immediately before takeoff, The autothrottle may be armed by selecting the autothrottle switch to autothrottle arm. The green light adjacent to the switch illuminates, and AT appears next to the selected thrust mode on the PFD. When ready for departure, the thrust levers should be advanced to 45% N1 and either toga button pressed. The autothrottle mode displayed on the PFD will turn green, and the thrust levers will advance to the target N1. If achieved N1 is more than 1% below target N1, the takeoff should be abandoned. When the wind speed is greater than 25 knots from a direction 55 degrees or more off the runway heading, do not use toga reduce. Also, perform a rolling takeoff and set takeoff thrust when aircraft ground speed equals wind speed. Takeoff performance is scheduled on the basis that the thrust levers are not moved during the first and second segments of the takeoff. At 80 knots, the thrust level calculated by the FADEC is frozen and the autothrottle is clamped until 350 feet, when FADEC unfreezes and the autothrottle enters the inactive armed mode. The autothrottle remains in the armed state until a new thrust mode is selected by the pilot or is automatically entered by the flight guidance system. Following an engine failure below 350 feet, if full thrust is required during a reduced thrust takeoff, a toga button must be pressed and the thrust levers manually advanced to the bugged value. After the flaps are retracted, thrust rating is set to climb norm by either pushing thrust on the MCP or selecting climb norm on the TRP. Climb norm normally remains selected on the TRP for the remainder of the flight. After the flight director captures the selected altitude, the autothrottle now enters speed mode and thrust automatically reduces to maintain the selected IAS Mach. The climb normal rating continues to be displayed in the N1 set windows. Descent may be made in either level change or vertical speed modes. Selecting Level Change places the autothrottle in retard mode. The thrust levers retard for 12 seconds before the autothrottle enters the armed mode. In this mode, full manual control of the thrust levers is available. Selecting Vertical Speed places the autothrottle in IAS or MAC mode. IAS or MAC as selected on V-cell will be maintained by the autothrottle. Vertical speed is controlled by the aircraft attitude through the flight director and autopilot. During an ILS approach, when the autopilot is in glide slope mode, the autothrottle enters speed mode and controls the speed to that selected in the V-cell window. At 50 feet radio altitude, the autothrottle enters retard mode, irrespective of autopilot engagement. The autothrottle should be disconnected on touchdown before the IAS is less than 60 knots. If a go-around is initiated by clicking a toga button below 2,000 feet radio altitude, the thrust mode automatically reverts to GA max. This can be reduced to GA reduce by pressing toga on the TRP. Post-flight. After checking the APU generator output, engines 1 and 4 may be shut down during taxi. However, to ensure adequate internal cooling, the engine must have been operated at flight idle or below for a minimum of 2 minutes before selecting the thrust lever to fuel off. As a maintenance check, the pilot is required to test the fan overspeed shutdown system on each engine every day. The N1 of all engines should be increased to 30%. The engine overspeed button on the ground test panel for the engine to be shut down first, normally the number 4, is pressed. After N1 begins to decay, the thrust lever should be moved to the fuel off position. Engine overspeed illuminates on the central warning panel. This indication should be cancelled by selecting Flight Start to On and Start Select to Engine 4. The remaining engines may then be shut down using the appropriate engine overspeed buttons. Start Select is rotated to the relevant engine after each shutdown to cancel the central warning panel warning. TRP off. With the TRP selected off, the interface between the FADEC and the flight guidance system is broken. The following functions are now not available. The autothrottle cannot receive thrust level commands, so is inhibited. N1 compensation. All computed thrust ratings. AF ARINC fail appears in the N1 set windows. Trim arrows. N1 ref and N1 redu must be calculated using the tables provided in the checklist. It is recommended that N1 ref is manually set in the PED N1 set window closest to the flying pilot, whilst N1 redu is entered in the other three windows. It must be noted that the N1 values presented in the tables of N1 for takeoff and go-around take into consideration N1 compensation. Therefore, with compensation not available, 1% must be subtracted from the values derived from these tables before they are entered into the PED. After takeoff, N1 should be manually set for the appropriate altitude and temperature as given in the tables in the MOM. Every 5,000 feet, the thrust levers should be advanced to the tabulated value. The pilot must monitor the EGT to prevent exceeding 613 degrees C. The FADEC will limit N1 to 97% and EGT to 649 degrees C. FADEC off. In order to protect against surge, the engine anti-ice of the affected engine must be selected on for the entire flight. If performance is limiting, the engine anti-ice of the affected engine only should be selected on. Performance data must be extracted from the appropriate tables or graphs at OAT plus 4 degrees C. If takeoff performance is not limiting with engine anti-ice on, all engine anti-ice should be selected on. If a single engine anti-ice is selected on, a discrete signal is sent to the TRP, which now assumes that all engine anti-ice is selected on, and calculates N1 accordingly. In this case, the TRP must be selected off by pressing either autothrottle disconnect button for more than 3 seconds. N1 for engine anti-ice off should now be calculated and manually set in the N1 set windows of the 3 unaffected engines. N1 for engine anti-ice on is set in the window of the affected engine. If the TRP is used during climb, climb norm may be selected. The N1 of the affected engine should be matched with those of the other 3 engines. During the descent, the N2 of the affected engine must be matched with those of the other three engines. In addition to the engine anti-ice of the affected engine being on at all times to improve surge margins, above 15,000 feet, either the associated engine air and pack or outer wing and tail anti-ice must be selected on. Above 31,000 feet, both the engine air and pack and outer wing and tail anti-ice must be selected on. The autothrottle must not be used with any FADEC selected off. FADEC fault. In-flight failure of FADEC is indicated by fault on the FADEC mode panel above the relevant engine. FADEC also illuminates on the central warning panel. The autothrottle should never be in operation with an unserviceable FADEC, so must be selected off. The engine anti-ice of the affected engine must be on at all times. In addition, to improve surge margins, above 15,000 feet, either the associated engine air and pack or outer wing and tail anti-ice must be selected on. Above 31,000 feet, both the engine air and pack and outer wing and tail anti-ice must be selected on. In order to protect the engine against invalid commands, FADEC fails in a freeze mode at high power settings. The relevant thrust lever should be retarded until engine control is acquired and the FADEC fault annunciator is pressed to select FADEC off. Normal FADEC off operations may now be resumed. It is not permitted to switch a FADEC on which had previously been selected off due to a FADEC fault. Engine fire, separation or severe damage. Following severe damage to an engine, it must be assumed that fire is present. The engine fire caption of the relevant engine may or may not be lit depending on the failure. If it is, the fire bell should be cancelled. After cross-checking between the pilots, the correct thrust lever should be identified and moved to fuel off. The high-pressure fuel valve then closes, and fuel is prevented from reaching the engine. If an engine fire is present, a red indication on the relevant fire handle will illuminate. This handle is pulled to the first detent. This action is confirmed by engine fire handle illuminating above the red warnings on the central warning panel. When the correct fire handle has been confirmed, it should be twisted through the detent and pulled to its full extent. This action isolates the electrical generator or hydraulic pump, closes the engine air valve, and closes the low-pressure fuel valve. The fire handle must now be twisted anti-clockwise to discharge the first fire extinguisher into engine zone 1, as indicated by engine extinguisher number 1 used. After 30 seconds, if the fire caption is still lit, the fire handle should be twisted fully clockwise to discharge the second fire extinguisher. If the fire still remains, the aircraft should be landed as soon as possible. If engine 1 or 4 has been shut down, the generator should be selected to off reset. The APU generator should be used within its limits. If engine 2 or 3 has been shut down, the relevant hydraulic pump should be selected off and the AC pump selected on. If engine 3 has been shut down, the PTU must be confirmed on. The relevant engine air should be selected off to extinguish the engine air valve NIPS indication. The relevant engine anti-ice should be selected off to extinguish the intake low pressure annunciator. Fuel may now be balanced to avoid asymmetry between wings. Engine oil low pressure. Warning of low oil pressure is indicated by an oil low pressure annunciator. If engine oil pressure is in the red sector or below 50 psi if N2 is above 80%, the engine should be shut down. If oil pressure appears normal, it can be assumed that the warning is false. Engine vibration excessive. Engine vibration is indicated on the PED. A value in excess of 1.2 will illuminate engine vibration on the central warning panel. If engine malfunction is confirmed or general vibration is present, the relevant engine must be shut down. If not, the autothrottle should be disconnected and the N1 of the relevant engine should be reduced to 80%. If the indicated vibration level does not vary with N1, it can be assumed that an indication fault is present and the engine may be operated normally whilst monitoring performance. If vibration does change with N1, reduce N1 until the vibration level falls below 1.2 and continue using the engine. If vibration level is still greater than 1.2 at flight idle, the engine must be shut down. Engine operating limitations. Click the mouse on different parts of the table to see the related notes.